All right, let's go ahead and get into it. Welcome back to Advent of Code in Swift. We are going to be working on day 9 today. I've got my coffee. I'm ready to go. And I figured out the ringing noise I was hearing yesterday. Turns out I have a small 7-inch HDMI monitor, like monitor in the sense of typically you would attach this to your camera, but it's facing me so I can see the stream and I can see my face and the screen and all that stuff. And I had one, it's a cheap device, and it had some like artifacts that were starting to grow on it. And I contacted Neewer, the company, and they sent me a replacement, which arrived yesterday or the day before the stream. I put it on and set it up, and I didn't realize that this thing also takes or has like a tiny cheap speaker in it. And so it was taking the stream audio and then playing it out of this tiny speaker with a little bit of a delay. It was just a horrible, like high-pitched ringing noise. And it sounded like there was some little bit of feedback, but anyway, it's fixed now. Everything's much better. All right, let's start reading. Day 9, Disk Fragmenter. Another push of the button leaves you in the familiar hallways of some friendly amphipods. Good thing you each somehow got your own personal mini-submarine. The historians jet away in search of the chief, mostly driving directly into walls. While the historians quickly figure out how to pilot these things, you notice an amphipod in the corner struggling with his computer. He's trying to make more contiguous free space by compacting all of the files, but his program isn't working. You offer to help. He shows you the disk map, your puzzle input he's already generated. For example, the disk map uses a dense format to represent the layout of files and free space on the disk. The digits alternate between indicating the length of a file and the length of free space. So a disk map like 1, 2, 3, 4, 5 would represent a 1-block file, 2 blocks of free space, a 3-block file, 4 blocks of free space, and then a 5-block file. A disk map like 90909 would represent 3 9-block files in a row with no free space in between them. Each file on disk also has an ID number based on the order of the files they appear before they are rearranged, starting with 0. So the disk map 1, 2, 3, 4, 5 has 3 files, 1, 3, and 5, with the IDs 0, 1, and 2. Using 1 character for each block where the digits are the file ID and dot is free space, the disk map represents these individual blocks. Okay. Is it always going to be just a single character? All right. So the first example above represents these individual blocks. So that's file ID 0 and it's 2 blocks. This is file ID 1. This is 3 empty spaces. Then file ID 1 is 3 file size of 3. Okay. The amphipod would like to move file blocks one at a time from the end of the disk to the leftmost free space block until there are no gaps remaining between file blocks. For the disk map 1, 2, 3, 4, 5, the process looks like this. Okay, so I definitely want to start in my algorithm to output this grid every step of the way for me to be able to visualize this. Okay, so on this one, for the disk map 1, 2, 3, 4, 5, the process looks like this. So we start off with everything laid out the way it is. Then this one takes file ID 0. Let's see. These individual blocks. So this one is the 1. For 1, 2, 3, 4, 5, the process looks like this. Oh, just file blocks one at a time, from the end of the disk to the leftmost free space until there are no gaps remaining between. Okay, so we're chopping off 2, putting it in the free space here. First example requires a few more steps. So we're going to take the 9 and shuffle it here, and this 9, shuffle it there, that 8, shuffle it there. Okay. The final step of this file compacting process is to update the file system checksum. To calculate the checksum, add up the result of multiplying each of these blocks' position with the file ID number it contains. The leftmost block is in position 0. If a block contains free space, skip it. Okay, so we've got 2 examples, one easy and one harder. So let's go ahead and grab our project. I'll do just prepare 9. All right, we'll go into our package and add our 9th day here. Day 9 tests. Let's grab this. Enum day 9. Is this font size big enough for the stream? I could make it a little bit bigger if we need. Looks pretty small, actually. Okay. Let me know how that is. All right, so this is going to be static func part 1. Input string returns a string. Let's go grab day 9 tests over here. You know what I found out yesterday, actually? I didn't realize you could do this, but you can just have free functions, which is pretty awesome. So I could do day 9 part 1 example. Input is 1, 2, 3, 4, 5. And I want to be able to step through this one at a time and sort of assert individual things out of this. So we'll have some sort of data structure that we can return, and then as I go through the defrag process, I want to defrag it one step at a time. So we'll have a defragmenter. We are going to be parsing our input with it's going to be a file ID. And I think this would be an enum. Block isn't the right term here, because I would have a file with some sort of file ID, which would be an int. Or I'd have free space. This would be length, ID int in length, and this would just have length. Entry, maybe? What did I call it? Okay. Okay, so if I do static func parse input gives me an array of entries, then I can write a test here. I can write a test just for the let entries is equal to, and we'll make this equatable. This is going to equal entry dot, let's make this like this so I can do it a little bit easier. Entry dot file with an ID of 0 and a length of 1. That's going to be day 9 entry. Okay, then the free space with a length of 2. Then a file with ID 1 with a length of 3. Free space 4. And a file ID 2 with a length of 5. Okay. So this is going to be day 1 parse entries. Sorry, day 9 parse entries. This is going to be day 9 part 1 example, which I think there's a way to mark this as pending, and I already forgot how to do it. Skip. I think. Test traits. Disabled. Okay. We'll start off with a failing test. I guess the only downside of this freeform function test is that I can't easily run all of them. Okay, so let's parse these into our entries. This one is going to be let digits is, I will do input trimming white spaces and new lines, and then we'll map each one into an int. All right, so then we'll start off with our ID counter, our file ID counter. I wonder what the best way to do alternating. It could just say is file or something, but or if it's an odd entry, then it's a file. I'll do that. So we'll do digits dot enumerated. That's going to be dot map. This is going to give us our offset and our digit. And then if the digit if it's even, then it's free space. Otherwise, it's file ID +1, and then I'm going to need explicit returns here now. We don't need that. Compact map string int is no member enumerator. I don't want parsers.compactMap. Is that what I want? Let me just double check. All right, input's a string. We trim that, we get a string. It's weird that we're getting a parsers.map here. And if I do this, then digits is an array of string.element, which should be character. This is what I want. Compact map, transform character in. Oh, I think maybe because I need that to be a string. So I'm going to do int string character. Now I should have an array of digits. Yeah. And I need this to go after. All right, so we can parse our input correctly. Now if we move over to the example and we're going to start defragging this, we're going to have all of our entries. We also are going to have some sort of layout. Like given the entries, I'm going to produce this layout, but as soon as we start moving stuff, like if I take this 2 and move it over here, the entry isn't really helping anymore. So I almost want to turn the entry into a layout. And then the layout could be, let's see. The layout at the moment can be, let's do an enum for a block. And then this is the file ID. The file ID or free space. Okay, so if I do this, then this seems like it could work. Entries, we switch the entries. This could then be switched to a flat map. I also kind of want to mark the index of where the free space is. Next free block index. So that I don't have to like do a linear scan every time. Okay, so this repeats the file's ID that many times, and then this repeats free space that many times. So we should have our defragmenter, when we create it, should have a layout. So let's do that. We'll do test func day9 defrag creates layout. And I want to print this out. So I want to do custom string convertible here, var description. And this is going to return the file ID. So that way I can grab the layouts description. defrag.layout, and we're gonna do I kind of wanted to say description here. No, that's not right. Let's do an extension on day9 dot. No, we'll do an extension on array where the element is equal to day9 dot block. And this is going to do self.map.description joined. Yep. Layout string, and this one is going to be and it's going to be 0 dot dot 111 dot 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 22222. Right? 1 2 3 4 5. All right, so that works. And so now when I do one step of this, then I'm going to say defrag.step. That's going to be mutating because it's going to change the layout. So that's going to be layout, and this will be mutating func step. I think I also need to do last file block index here. If next free block index is equal to nil, then we're going to say let's do it after this one. Oh wait, no. We're gonna do right before. So we're about to append, so it's whatever the length is right now. That's going to be next free block index is equal to the layout.count. Then here, we're going to be appending if the last file block index is nil. Well, we don't really care what it is. We're just always going to be appending last file block index is equal to layout.count minus 1 here. So I think that somehow we need to know if these things cross each other, or I don't really know how do I know to stop. Maybe step returns a Boolean or something, but for now I'm going to take the next free block index, else return. We're going to grab both last file block index, comma that, else return, and then we can swap them and update the IDs. All right, so we swapped them. Now we need to update those pointers. So this is going to, last file block index is going to check, let's see, if the layout at last file block index, let's also check to make sure file block index is greater than 0. And the layout is file, maybe not equal free. Then we'll do that. And then the next free block index is going to check the next one in the list. If that's true, that if we don't have any files left, or the one before this is free space, yeah, I think this is wrong, but it'll get us to pass this test. Hey Samuel, how are you? Good to see you here. If the next free block... What I'm trying to avoid is just walking through the array over and over and over again, which may be the move just to get this going. Good, making progress on my app. Nice. That's always a good feeling. All right, so if we have space, no, next free block is not at the end. Yeah. We'll move it forward, but we only want to do this if it's... if the layout at the next free block +1 is equal to free. Then we'll move it forward, otherwise we'll set it to nil. Okay, so at this point now we expect this 2 to be put here. And then there to be a free space on the end. All right, I'm just going to continue to do this. So we'll do a var layout. So this is going to be step 1. Then step 2 is going to have free space at the end. That one's going to be 2. Test failed here. We expected there to be... Did my step... let's see. Yeah, it didn't move it. Let's step through it. All right, first one we know is fine. Second one, we have our last file block index is nil. So the last file block index was greater than 0, and the... oh, I needed to do -1 here. That'll do it. Okay. Now if I do another step, we expect this 2 to be replaced there and then go here. And this I don't think is going to work because, well, I know it's not going to work. When I run it, we're going to get this problem here, this free block problem. So the last file block so we basically don't know we're done until all the free space is at the end. Which means that I think that those 2 indices have crossed. Okay, so I'm going to say while last file block index is greater than 0, and the layout for last file block index -1 is not free, then we're going to do this. And I'm not going to set it to nil. And then I need to do the same thing here. This actually needs to be while it's free, right? So we started here. Then we moved backwards. At some point, I'm going to move backwards and the number is going to be free. I think I need to just subtract it. We're just going to do self.lastFileBlockIndex minus equals 1, and then we're going to break it if it's a file. Break out of the loop if it's a file. This is annoying. If I do vars here, then I can treat them as non-optional, but I just have to make sure that at the end I set last file block index equals last file block index and next free block index equals next free block index. I just need to make sure that we do that. Okay, then this one is going to be while we are not at the end of the string. We're going to do next free block index plus equals 1. And then if case dot free is that one, then we're going to break out. And then I still don't know like when I'm done, other than I've just broken out of this loop again. If I call step, it's not going to change anything. Okay, so test succeeded there. So somehow I need to know that the last file block index and the... Yeah, so let's just have this return a Boolean of whether or not we're done. Yeah, we're defragging. All right, so we're going to return that the last file block index is less than the next free block index. Okay, so that gives us defrag step. Let's do defrag to the end. I also think I could maybe do discardable result here. Because I don't necessarily care. So then this one can do mutating func run that just calls while step. That's a little weird. But that works. I thought that sounded like what you're doing, then I saw the code, yeah. All right, so we're gonna do defrag run. This time I'm just going to do defrag dot run, and then I expect the layout to be 2 and dot. Let layout equals defrag dot layout string. Okay. It didn't work. Oh, sorry. That needs to be while step is false. That only did one iteration. Um... 02211. Do I have too many? It would be nice if these were aligned. I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. The length of the string should never change. That's 16 characters. This one is 15 characters. I guess I just had one too many. Okay, so our defrag now runs on our tiny input. On the bigger input, we expect this one. That was this. We're gonna do let entries. We can just use parse this time to make our lives easier. day9.parse input, and then we're gonna get a defrag. Is a day9.defragmenter. defrag.run. And then we're going to expect that this layout.layoutString. And that's going to equal this longer one. Okay, we've got some problem there. So my layout is not correct. We could check each step. That might actually be helpful. So that's going to split on separator new line. So now we're going to have our expected layouts. Let's do that. And instead of running, I'll do while expected steps is empty is false. We'll do a defrag step. At this point, we expect the steps to Let's see, let expected remove first. So on the last one, we do expect it. I think that's fine. Maybe we just don't care about that. Then we get the layout and we expect layout equals expected. Okay, so our expectation failed. I got 13 of them. It failed every step of the way. All right. Let's take a look at the first one. It's strange that this ended up becoming a 1 and a 1. Where did that even happen? All right, we're going to run this one step at a time. Okay, so our expected is 00111 and ending in 899. Yeah. Okay, so then we run our defrag step. Our next free block index is considered to be 0, which is not correct. How did it get that? This one should have given us a value of 2 for the next free block index. And it didn't because we're doing it too soon. Right, if I rerun this test, our length is 2. The layout has no values yet. That's weird. How are our entries giving us 2? Is our parse function doing this correctly? All right, so we have now 19 digits. The first one is a 2. And so our file ID is 0. That should be what it's doing. Not digit. Offset. Yeah, it's funny because the initial example was 1, 2, 3, 4, 5. So of course the offset and the digit are both going to be odd and even together. Okay. Let's see. did I do that wrong? This needs to be here, and this needs to be here now. Because if it's 0, it's a file. If it's 1, then it's free space. Then it's 2, this file. Yep. Yeah, this looks more correct. Test failed. We got 13 failures. All right, so step 1, 009 ... with a dot at the end. 009 ... sorry, this is the input. We're off by 1 there. Okay, yeah, that test succeeded. Okay, so finally, to do the checksum, to calculate the checksum, add up the result of multiplying each of these blocks' position with the file ID number it contains. The leftmost block is in position 0. If it contains a free space, skip it. Okay, so now let's do the checksum. Checksum gives us an int. This is going to be blocks.enumerated, or what I call that, layout.enumerated. We're going to reduce 0. Add up the result of multiplying each of these blocks' position with the file number. Oh yeah, so this is going to be, we're going to reduce to 0, and then this is going to be the sum and the block in. If the block, this is going to be block position, let's just call it element. Item maybe, I don't know. Okay, if it's a file, then we're going to do return sum plus the file ID number with its position. ID times item.offset. And if it's free space, we just skip it. All right, so we're going to do this same test. This is going to be example checksum. We don't care about the expected steps here. We're just going to say dfrag.run and expect that the dfrag.checksum is equal to 1928. Okay, that worked. And this is this will end up being our part 1. So let's go over here and add our day 9 part 1 function. Is going to do this. We're going to parse the input. We're going to create a defragmenter for those entries. We're going to run it until it's over, and then we're going to return the string of dfrag.checksum. All right, let's paste in our input. Holy moly. That is a lot. And I think that what I want to do is debug. Every time through after I'm done. Is to if debug will print out the layout.layout string. And then I could also print out these indices. So it would be something like print, I don't know. Well, I think it's fine for me to just check the individual steps. Because I kind of want to say, let's also make that debug method equal false. Same thing for the run method, so you don't have to specify it. Let's go grab our main function. Okay, I got a number. I do want to see what this looks like if I say debug true. That's probably not super helpful here. I wonder if it works better if I do Swift run. What is happening here? Invalid manifest. Clearly not. Yeah, so this is still running and trying to print everything. All right, while that runs, let's go paste in our number. Okay, part 2. Upon completion, 2 things immediately become clear. First, a disk definitely has a lot more contiguous free space, just like the amphipod hoped. Second, the computer is running much more slowly. Maybe introducing all that file system fragmentation was a bad idea. The eager amphipod already has a new plan. Rather than move individual blocks, he'd like to try compacting the files on his disk by moving whole files instead. This time, attempt to move the whole files to the leftmost span of free space in the blocks that could fit the file. Attempting to move each file exactly once in order of decreasing file ID number. Starting with the file with the highest file ID number, if there's no span of free space to the left of a file that is large enough to fit the file does not move. Okay. So 99 will fit in that free space here. And then 888 doesn't fit anywhere. 777 can fit there. Okay. I don't know if this is going to be terrible for performance. Oh man, printing this out is not the greatest idea. Let's just stop it. I'm not sure what I'm using the correct Xcode. I'm not sure what is happening here where it says invalid manifest. Package description version 6.0. Swift version 6. Am I... Yeah, it's declared up at the top. Yeah, I don't want to get hung up on that part. All right, so part 2. So when we call the defrag, I think my defragmenter is going to have whole files true or something like that, so that we can do more than one thing. Whole files true or bool equals false by default. Whole files boolean. Okay. I'm going to replace this with step block. And this is going to say if whole files, then do this, otherwise step block. And let's make another one called step file. These can be private. The interesting thing now is that I kind of want to go back to having the entries, because then it will be a smaller scan to tell me where the files are. Like, instead of having this layout, if I had entries, this wouldn't be here. It would just be entries. And layout wouldn't be here at all. This would have to... Let's make a function called I definitely don't want to convert the entries to layout every time. Seems very slow. Let's comment out step block for now, which means it's going to do nothing. Maybe this would be better to have 2 defragmenters. I think it would. Let me go back. Just so I avoid breaking everything. All right, so this is going to be a block defragmenter. And I think I can just close this. There we go. And then I'll do a struct file defragmenter. This one is going to take the entries and I think the interesting thing here is that when we are splitting the file, so if we have like .file1, comma .free3 and .file2, when we take this file off the end, then we're going to be looking for the first free space whose length is less than or equal to that. So then after that step will be file1 .file2 .free1. So here, this is going to return a Boolean to know if we're done. Being able to know where all of the file indices are is going to be helpful, as well as the free space indices. So maybe we compute those up front and just keep them updated as we are iterating, so that as we go through our steps, we don't have to continue to scan. Though we're scanning on entries, this is going to be a much smaller array, right? It's going to be the size of our input, not the size of our input expanded. So this is, let's see, one line, which is 20,000 characters. Yeah, it's still pretty big. All right, let's do file indices. And free space, free indices. Okay, so then let's compute this. So for entry, no, this is index entry in entries. If it's a file, we're going to append file. If it's free space, we'll do that. Okay. So now when we step, we need to take the, sorry, that needs to be enumerated. So we need to take the last file. We know that the file indices, at least at the beginning, starts with this one. I actually don't know how I want to do that part. Because as soon as you skip over a file with a larger ID that doesn't fit, it's almost like we need to know the current file ID. Let's say that this, the file ID is going to be self.entries for, let's see, if let file indices.last. This is going to be file ID equals entries I. Oh, but that's... Yeah. So then file ID can be ID. We don't care about the length in this case. We just care about the ID. If we can't find it, this is a problem. This is going to be like no files to defrag. Okay. Now we know those are in order already, so that's good. So now we can just subtract from that. It kind of means that these file indices can be an int to int. Let's do let ID. Yeah, that's better. So then I think file ID is just going to be iterated over each time through. It's kind of weird here that this is not complaining about this not having a value. Like if we got to the end here, our file ID is an integer. It's just kind of strange. Maybe it starts at 0. Which would be kind of a problem. Let's just make sure assert file ID not equal -1. No files to defrag. All right, I think that's okay. Okay, so now what we're looking for is, let's get the file block. The entry is going to be entries for file ID. I mean, this should exist, but... Oh, yeah. Entry equals entries for file ID. So that gives us our entry, and we know it's a file as well. So let's guard case. We need to know the length. So .file, we know the ID already. Let's just do an assert there. This is... We're going to fatal error here. Because entry is not a file. That would be a problem. And we also want to assert that the ID is equal to the file ID. Okay, so now we have the file length. Now we need to search for free space. So now we can look at for index in free indices. We're going to guard case.free let free space equals entries index, else continue. I suppose I could also add a fatal error there or an assert or something, but that's fine. Okay, if the free space is greater than or equal to the file length, let's rename this to file length, then we can fit the file here. So now we need to look at remaining space. Let's see, we are going to put the file we're going to do entries.insert. Ooh, this is going to be problematic because I've cached all the indices and now I'm going to insert them all. Okay. Entries.insert .file ID length, file length at the free space index. Let's see. Remaining space is going to be file length minus free space minus file length. If there's if the remaining space is there, we're going to grab index plus 1. No, insert. Because we just replaced no, we definitely just want to swap in the item there. Okay. Equals file, no index. Okay, so we put the file, we can fit the file here, which moves that there. Entries, what do we call these? File indices for this file ID is now index. If there's remaining space, we need to insert a new element, a free with remaining space at index plus 1, and that means that we need to shift all indices after this one by 1 because we just invalidated it. That part kind of sucks. Let's see, do the file indices change? They do. So it's going to be something like file indices.map values. But that gives me just values. Where the value is greater than the index. So any file ID that is now greater than the spot that we're in, we need to say, yeah, and we need to do the same thing for the for index, other space index in free indices, where other space index is greater than index. But I just did this one. Let's see. No. Not entries. Sorry, this needs to be free indices. And that needs to be here. Then we're going to insert at index +1 free indices dot append index +1, and anything beyond that this part is hard because I don't want to increase this one. But that means that there could be two free spaces in a row, and we might at some point want to join them. Oh, we definitely have to join them, right? If we move a file into free space, it could be surrounded by multiple free space, and then we need to reclaim those as one. This index caching is probably going to be the death of me. I thought it was a good idea. It might still be a good idea, but it's just certainly more difficult. All right, so what I'm looking at here is, do I still have that comment? Here. This is kind of what I'm looking at. And let's say there's free space at the end of like 5 here. Okay, so here the indices for the free space are 1 and 3. Here the indices for the free space become 2 and 3. Because we take file number 2, we move it over here, which would normally insert everything after this one stays the same. Everything before it shifts. So that's also a problem. I could go back to just linear scan every time, but that seems really wasteful. Oh, also these needs to be sorted all the time. So I can't just insert, or I can't just append. I have to insert it at the right spot. Okay, so the old index of this file we need. Old file index is file indices for file ID. And we need that because everything after that stays the same, but everything between the index and this one gets shifted up. Because the reason why I'm doing all this work is because searching through these free indices is going to be much cheaper than doing a linear scan over everything every single time. The hard part is that I need to know, given, you know, A, B, C, D, E, and some cached indices of each, that if I take D and insert it before B, so that would be A, D, C, A, D, B, C, E. Then the numbers, so D changes, we already had that. B changes to 2, where it was 1. So that index that we're replacing up to the old index. So C becomes 3, but then E is 4. So if it's greater than the old index, we don't care, because everything would have shifted anyway. It's kind of weird because I want a set that's ordered. Kind of. Because this is going to be terrible. I don't want to remove all. I want to remove first where or something. Yeah, there's no... I'm probably just going to have to say for index in free indices if the index, sorry, this needs to be I. If I is equal to the index, then we're going to do free indices dot remove at I. No, that's not right. Free indices I equals that index. Yeah. And then we can break out of the loop. So that way we get to the first one and we're done. Okay, so this index is no longer a free space. Remove it. If we have free space after this file, add it. Remaining space is free space, file length, etc. If there's remaining space, we're going to insert a free remaining space. There's one more case we need to add, which is to compact. If we just inserted free space, then we need to compact those two elements into one free space. Ugh, I feel like I'm going to run out of time. Entries.insert at index. I could maybe go through a inefficient compacting step at the very end and just say, like, look at all of the free space indices. The problem is then I have to shift them again, which sucks. Okay, so in the file indices where the value is greater than the index and val is less than the old index. Which, where was that? Old file index is this. Why is that optional? Let's just unwrap it. We know it's there. Or it certainly should be there. Okay. So we need to adjust file offsets or file indices. Adjust space indices. So we just inserted free space. Let's say after inserting D, we also had to insert an X. That also means that these file indices need to be adjusted no matter what. After we do this. And then I need to do it again. This is... yeah, I need to do it again for everything after this, because then if I insert an X here, then this becomes 2, and each one of these need to be +1. Okay, so other space index in where this one is after this one. Free indices, other space index plus equals 1. And then we're also going to do the file indices one. Okay. I have no idea if this is going to work. Okay, we need a run function. The other thing is I don't know, in the file defragmenter, I need to return a Boolean when I'm done. I suppose that I'm done if the file ID that I need to subtract at the very end. Let's see. At the very end of my step, I need to decrement file ID. Guard file ID is greater than 0, otherwise return true that we're done. Then I can defer decrement file ID after stepping. And then at the very end I can return false. Okay, the checksum is going to be the same function, but I will need to convert it to a layout first. Let's do... Yeah, I'm just going to copy it. And then I need a function to convert this to a layout, which I have here. I kind of want this layout then to be a first class type so that I can call layout let blocks is an array of block. I can init with entries to create it, and then this thing can have a checksum. Let's copy it exactly how we had it. I don't trust Copilot in that case. Okay, this entries is going to be this. All right, so we've got blocks for each entry, blocks.append, blocks.append. Oh, damn. These will need to be part of the... Yeah. Okay, so now I should be able to say layout equals layout from entries. That becomes blocks. This is going to be layout and layout. Unwrap condition requires a valid identifier. Oh yeah. Last file block index equals. Okay, so now I can set that on the layout. Blocks is a let constant. I also can do subscript. So this is going to be var, let's do private var blocks, and then we'll do subscripting. Okay, our layout string now is just a method on here, which is great. Okay, what else are we missing here? Our checksum for file defragmenter is not done yet. Here we need to do count for layout. Let's just add a count method. Count is blocks.count. Okay. Our block defragmenter, I think now is working. And now we get a, yeah. So now I want to be able to say, give me a layout for those blocks. So I'm going to say layout for my blocks. And then what is it called? Entries. That's going to give me all of the blocks. Or sorry, this is just checksum. Yeah. Okay. Defrag dot layout dot checksum. We have no run function on file defragmenter, but that's going to be the same as this one. I also don't need the checksum to be like that. Because this is just going to be .layout.checksum. Oh wait, I don't have a layout, so I do have to do that. Yeah. File indices passed by reference before being initialized. True. All right, build succeeded there. Let's go over to day 9 tests, and let's go back and start running our tests. Make sure that I didn't break anything there. Defrag, checksum. That needs to be .layout.checksum. Okay. So day 9 tests all worked. So now we need to look at part 2. I don't have any tests for part 2. First example above now proceeds differently. So this is going to be the step each time. I still don't have the compacting part. So day 9 part 2 example. Example steps. So it's going to be like this, except we're going to be using file defragmenter. And then these are my expected steps. So it's going to be like this. All right. These are going to change to the smaller number. I'm going to get rid of the first one. And we don't have a layout for the file defragmenter. I think that maybe we do have entries. So maybe I could add a layout function, which returns a layout, and that does layout of entries. And now this one can do layout.checksum. I want it to be a function to indicate that it's doing work rather than just returning something. Okay, and I expect this one to fail. Entry is not a file. Okay, we're already catching bugs. All right, so let's take a look at our entry. I don't know how many steps we actually took. Maybe this is the first one. What is the file ID? File ID is 9. That seems correct. Entries. That's not right. Yeah, this needs to be file index. Is file indices for file ID. That needs to be file index. Okay. Not sure how many iterations we went, but let's see. I is 9. Free indices has 8 elements in it. No, it has 9 elements in it. I is 9. This is wrong. This needs to be dot enumerated. This is free index and I. If free indices at position I is that, then I need to remove the free index. Is that right? This is my enumeration offset, and this is the index value that's inside of it. We're looking for number 9. That corresponds to free index 4, and we need to remove that. Wow. Okay, still incorrect. This time our free indices is that. Our free index is 4. Free indices of free index. So we're searching for, what are we searching for? I don't actually need this anymore. This needs to be if I is index, then remove it. I is 9, and the index we're searching for is 1, which is this one. So it should have found it already. Okay, we got past that one. Now we have free space after this file. We need to add it. Okay, for... Yeah, this is wrong too. This needs to be enumerated. Let's do offset. Offset. And then this one is a dictionary type, which I think will still be fine. Okay, interesting. Yeah, step after moving everything, our entries... Did we not change our entries? We should have. All right, so let's look at our entries. And the file ID that we're looking for is 8. Okay, so if we take a look at layout entries dot layout string, that's day 9 dot layout. We didn't remove the last one. That's also a problem. So we created a new file at this one, but entries at the old file index. We just need to remove. I don't think that's the problem though, because we're looking for file ID 8, which is this one. File ID 8 is at entry 17, but it thinks it's at 18. Yeah, let's run through this one more time just from the start of it, and I do need to run here in a minute, but all right, the file index is 18, and the file ID, let's grab that file ID. What we're looking for is 9. If I look at the layout string and then also the entries, there is no index 19. And this is the first time through the loop. File index 18. Where did I get 19 from? Did I miss something? File index is 18. Yeah. Okay. Okay, so then oh, I don't need to adjust anything here. because at this point, well, I only need to adjust things that are after the old file index to subtract them. Yeah, because at this point I've removed a file. If I remove it at the end, it doesn't matter. And all I did is replace the free space index with that one. So the only one that needs to be moved then, if there's free space remaining, if we have free space after this file, add it, we'll get the remaining space. Then we insert it, and then everything past this needs to be added by one when we insert. Okay. Okay, so we're going to search for free space. We found some. The old file index is 18. We assign that one and then remove it. So at this point now, if we look at our layout, 9 is gone. We inserted the 9s in that spot, but we ate all the free space, which we didn't want to do. There's actually more free space. And so we're going to insert it here. So now we have our free space dot there. Our free indices needs to be sorted when we insert. I guess the free ones don't. The file IDs need to be sorted. No, they don't. We're in a dictionary. Maybe we don't need to sort at all. We need to sort when we compact so that we can see if two numbers, if any of the numbers are only offset by 1, then we can combine them and then adjust indices again. I wonder if all of this stuff is just like when I make a swap, just recompute all the indices. But then that's probably just as bad as just doing search. Just like give me all the indices and find a free space one. It's certainly possible that this is just as bad as that. So for each one where the other space index is greater than that index, we're going to offset it. Let's continue. So we got our first issue. 0099.111.2. Oh, we need to append that free space on the end. That's what we didn't do. So wherever the file was, we need to put the free space there. The remaining free space. Yeah. So entries at the old file index, we're not removing it. It's just going to be the free space of file length minus free space. Yeah, let's do remaining space as that. If there's remaining space, then we're going to do this. Otherwise, we're just going to remove at old file index. And then this adjusting only needs to happen here. So now we have remaining space down here, which we don't need. If we have free space after this file, we add it. Sorry, this one is not correct. This is going to be the file length space that we added always. And then the remaining space can go down here. Is that true? We take the, yeah. We always do this. We take the old file index. Yeah, we don't even need to do this. The old file index will always be the file's space at the end. And then we'll see if we need to insert free space. All right, seems like step 2 failed this time. And this one is 888 skipped over. Then we're going to 777, and it should have put it here, but didn't. Okay, let's take a look. So file ID is 9. We're not gonna, we know that that works. Then we skip over 8. So we're looking for a free index that fits, and we won't find any. Okay. Return false. So now we're running it for 7. This free space should be 1. Because if we look at our layout, well, I think I appended that onto the end of free space indices. Yeah. Wait. That's 0, 1, 2. Yeah. Okay. That's correct. Okay, so the free space that we have right now is this one, and it's a length of 3. Sorry, this one. It's a length of 3. So it says we can fit it here. The old file index is 15. We're going to put this at index 4. Seems like this would have put 777 there. Yeah, it should. And then the rest is just adjusting indices. So we're looking for index, which is 4. Okay. Our remaining space at this point is 0, so we don't need to do anything. So oh, what happened here? Oh, we're looking over free indices even if we found it. Yeah. If we found it, we're going to return here. All right, we're going to look at number 7. We found free space. The index that we're going to be putting at it is 4. So if we look at our entries, yeah, we're going to be putting it here. And then the old index is free. Then we're going to update file indices for file to be that index. That index is no longer a free space. We remove it. And we have no remaining space, and we return false. Expect layout equals expected. Am I off by 1 on this? The expected string has the 4 in place. Okay, we have 3 errors. Oh, because step didn't change anything. Yeah, we return if we didn't change anything. So I don't think I want my... Let's see, when we go to do our step, we're only decrementing at the very end. Let's see, we could say something like made swap or something is false, while not made swap, and file ID is greater than 0. Then we're going to do all of this stuff. Then at the end of this loop, we're going to say file ID minus equals 1. We could do made swap here, but we don't actually care. We're just going to return. Yeah, we don't even need the made swap thing. So while file ID is greater than or equal to 0, I need a return true somewhere. I guess it's going to call it again and work. Yeah, I wasn't expecting that step to do nothing. So if we got to the end, then I'm just done. I can return true there. So while file ID is greater than or equal to 0, we're going to search, we're going to subtract, etc., and then we're going to return true. If we found one, we're going to stop and return false. Let's try this test again. Okay, now our file ID is 3. Okay, so we're on to a new error now, but this is a good stopping point because I'm out of time. I wish I could get these done in a shorter time frame, but oh well. But thanks for joining, and I will probably do the rest of this off camera if I have time, but I'll be back for day 10 tomorrow.